Right, so in this slide we summarize the difference between the iteration and recursion and discuss their relative advantage over the other. So the idea is that whenever we are able to implement some algorithm in a recursive fashion, there is also another iterative form of the same algorithm, okay, in which we typically write a loop, start with the basic value and build on top of that until we reach the desired value or the output of the algorithm. The recursive algorithms are more elegant, they are simple to express, and they are very simple to understand because they define them in terms of themselves. While the iterative algorithms are sometimes difficult to understand, but they're more computationally efficient, which means that they usually don't cause memory problems and they usually take less amount of time because there are not many calls which are generated. Okay. For example, for the recursive algorithms, uh, in the example that we saw for the Fibonacci sequence, we had an exponential number of calls. But this is usually not a problem with the iterative algorithms. So it is easier to describe algorithms as recursive algorithms, but from the implementation point of view, mostly it makes more sense um, to implement the algorithm in an iterative way. So this brings us to the end of chapter number 5. Just to summarize, we have discussed the principle of mathematical induction in both its strong form and the weak form. We talked about the well ordering principle. We defined what is recursion and gave several examples where we defined recursive sets, functions, and sequences. And towards the end, we saw how we can implement programs in terms of recursive algorithms. And we saw their advantages as compared to the iterative implementation and their disadvantages also.